Hello, beautiful people. Trust I met you well. Of course, I did. If not, why are you watching this video? All right, welcome back. This is our second class on probability theory, and today we'll be looking at probability with or without replacement. Okay, so what does with replacement mean? It simply means that if I have a couple of things to choose from, if I pick one, right, and I want to pick the other, let me say, okay, two markers, right? So what's the probability of picking a marker? A green marker with replacement. So I pick a green, right? I calculate the probability. I put it back. Then a black marker, like I pick a black, calculate the probability. I put it back, something like that. Okay. Now let's look at the question. So given the table below, answer the questions that follow. You have different balls, like different colors. So you have a red ball, frequency is 20, that is, you have 20 of them. 18 yellow balls and 12 green balls, right? So the question now says that what is the probability of picking a red and a yellow ball I with replacement? So after picking one red ball, right, you put it back, then you pick a yellow ball. Do you understand? Okay, so how do we solve that? Before moving into that, lest I forget, this frequency here, you might be given a table, and then the table here would have, instead of having a frequency, may have a relative frequency. Relative frequency. So relative frequency is already the probability of what you're looking for. So in case you don't have frequency, you just have relative frequency. So relative frequency is already the probability of each of the um, um, each of the items, each of the variable, right? Anyway, so now let's look at this. Um, so the first thing is to calculate our sample space. So solution. Don't worry, it's not at all. So solution. Our sample space is basically the total 20 plus 18, 38, 38 plus 12, 50. So that's it. That's our sample space. So the question says probability of picking. So I pick a red ball first. If I look at the red ball, you have 20 of it. Remember our formula N over F. So probability of a red ball is N over F. How many times do you have a red ball divided by the total frequency, that is the sample space. The frequency of, like, when you sum up everything, all of the items that you have. So we have 20 divided by 50, which is 2 over 5. Right? So this is the probability of picking a red ball. Then the question now says, and a yellow ball without replacement. So this is one I. So what this is saying is that, look at yellow ball, right? So here you've returned the red ball, so you still have 50 balls in total. Okay, then we come to yellow. Yellow is 18 divided by 50. Where is it? Yellow. Okay, so this can give you this gives us 9 over, what am I doing? Now about 25. No, there's no need, you don't really have to divide it. Who does this? Now you can let this guy as 20 over 50. So the formula for and, I think, did you do it last time? So probability of A intersection B, this is like the formula, right? For and is simply probability of A multiplied by probability of B Okay, and these are for independent events. Independent events. So like we are going to talk more about, there's a class for independent events, so like you are going to understand it very well. Well, what independent event is basically saying is that we are looking at two events that after one of the events has happened, right? The probability of the other events happening, right, is not affected by the fact that event A has already happened. So if you have two events, A and B, okay, and then we are looking at if both of them are independent, if they are independent events. So what we are trying to say is that the fact that A has already taken place, right, does not really affect the chance of B taking place. Do you understand? The fact that A has already taken place does not affect the chance of B taking place. That's what independent event, is talking about. There's a mathematical dimension to it. We'll talk about that when we get to the class on. But just note this anyway. And the The question is going to state if what you're looking at is an independent event or a dependent event. So here I'm assuming that we have independent event. So like, what is the probability of picking a red ball and a yellow ball, given that both events are independent? Do you understand? Or given that they are independent, then I so solve probability replacement and something like that. Okay. So here I'll just pick probability of A happening is 20 over 50 multiplied by probability of Y 18 over 50. So we're having 360 divided by 2500, and that is 0.14. So there's a 14% chance, right, that you're going to pick a red and a yellow ball without replacement. With replacement, sorry. Now, how about without replacement? So here, since we are picking the red ball first, so probability of the red ball is still what it is. It's still 20 over 50. But probability of the yellow ball, now, you did not return the red ball. So now your sample space has reduced to 49. And then it wasn't a yellow ball that you picked anyway, you picked the red ball. So like total number of yellow balls are still the same, they are still 18. 18. But now divided by the total, which is 49. Right? So P of R intersection Y equals 20 over 50 multiplied by 18 over 49. So by the time you solve that out, we'll be having 360 over 2, so we're having 0.15. You see? Is it hard? No. Okay, the next one, what is the probability of here? What I just did, I didn't want to write the whole thing again. So like this is still standing for what is the probability of picking, picking two green balls with replacement and without replacement, two green balls, right? So the last one, number 2, let's say I. So the first green ball, probability of a green ball equals green. That's you have 12 green balls, 12 over 50, right? So since you're picking two green balls, when you pick the first green ball, you calculate probability, and then you put it back, then you calculate probability of the other green ball. So essentially, you'll be having the same number. Okay, so probability of picking two green balls with replacement, you can just add it with replacement equals so 12 multiplied by 50 over 50, then multiplied by 12 over 50. So 144 over 2500, and then that will give us 0.06. Yeah, 0.06. I think approximately normally it's meant to give us okay, let me just write 0.0576. So it's approximately 0.06. So you kind of have like one to a 5.6% chance, okay, of picking two green balls without replacement. So the last one now is that's with replacement. Sorry, I don't know why I keep mixing these things up. And last one now is without replacement. So probability of picking, so I would have to. Do I really have to erase anything? Let's just try to manage. Well, in this case, the probability of picking the first green ball is still the same thing, 12 over 50, right? But now the probability of picking the second green ball, because the first green ball you picked, you didn't return it. Do you understand? So probability of picking second green ball without replacement, you've picked a green ball, you didn't return it. So how many green balls do you have left? 11. Then you've also picked a green ball, you don't have 50 balls anymore, you have 49. Alright, so to answer this question, you have probability of picking G and G with what I put here without replacement. Without replacement, so equals 12 over 50 over 50 multiplied by 11 over 49. Okay, I hope that's clear. And that gives us um what do we have? 12 over 50 multiplied by 11 over 49. We have 0.05. Yeah, 0.05. So you see, it's a pretty much simple thing. Okay. So if I were to fill up this relative frequency column now, I just use it to solve. Since it have been what you have here would have been probability of picking a red ball, which is 20. Maybe I should just put relative frequency here. But since you started with us, I believe you should know what I mean. So I'll put my RF here. So let's just assume that we use that place to solve, like a solving space, sample space, solving space. You feeling me? Okay. So RF is relative frequency. Don't forget. So for a red, but that's probability 20 divided by 50. If you even calculate it, that's 2 over 5. Okay. 0.4 is it? Then the relative frequency of yellow balls, that's going to be 18. 18 divided by 50. I get out of my head. That's like let me just put 18 over 50 there. Then for green balls, of course, that's going to be 20. That's going to be 12 over 50. So the values I have here, they are the probability values, right? They're the probability values of each ball. All right, I'm just telling you just in case you don't have a frequency in a particular question. What you have is like maybe items, right? The list under each variable, and then you have the relative frequency. Okay, so just know that what you have is already probability. But when we look at conditional probability, and maybe examples like the next two classes that are about, so you are going to see um, an example of something like whatever. Okay. So like the next thing we're going to now is the assignment on this particular topic. Okay, it may be long, but it's a simple assignment. So we have given the data below on Nobel Prize winners by countries. Okay. If two countries by countries, so people that have won the Nobel Prize. So if two winners are selected at random, what's the probability that you get with or without replacement? That is, first you calculate for with replacement, second you calculate for without replacement. To instance, so per question now, with replacement, without replacement. Okay, so what's the probability that you get A, an American and a German winner, B, a winner from other countries, and a winner from Sweden? Now, number two is a different question on its own. Find the probability that the winner is A, either from France, okay, either from France or Germany, and B, any country other than the US. Alright, so this is the tip that I'm going to use to do the assignment. So with that, we'll wrap it up for this class, and then we'll be looking at simultaneous events, like another interesting thing in probability theory. So far so good. I hope you've been enjoying yourselves. See you in the next class. Thank you.